complex numbers. Complex number 1 plus 2i is denoted by u. Polynomial 2x cubed plus ax squared plus 4x plus b are real constants, denoted by p of x. U is a root of the equation. So first of all, u is, let's say, 1 plus 2i. Okay, so 1 plus 2i is u, which means u squared is, well, this is a plus b all squared, which is a squared plus 2ab plus b squared. But remember that I squared is actually minus 1, so that's why we have minus 4. So 1 minus 4 is minus 3. In the simplest form, we have this for the u squared. For the u cubed, there will be u squared times u again. The u squared is this guy, the u is this, and then we multiply. Minus 3, minus 6i, 4i, 8i squared. I squared is minus 1, so this is minus 8. Minus 3 minus 8 is minus 11. So now we have the u cubed. So back to the original equation, which is the 2u cubed plus au squared and so on. We replace the u cubed with this, and the u squared with this, and the u with this, and then we simplify everything. Open up the brackets. 2 times minus 11, 2 times minus 2i, 8 times minus 3, 8 times 4i, 4 times 1, 4 times 2i. Then we group the real part, so minus 22, minus 3a, plus 4, plus b, just put it here in one bracket. And for the I, we have minus 4i, plus 4ai, plus 8i, so we combine everything here. And on the right side, because it is 0, we can just say 0 plus 0i. So this means the real part is equal to 0. We have this equation. And the imaginary part is also equal to 0. We have the other equation. So to solve for a and b here, we can just start with this green equation. Minus 4 plus 8, that's 4. Subtract 4 from both sides. And then we divide both sides by 4. And we get the a. After we get the a, just plug in this a value to this equation here. So we have minus 22 plus 4 is minus 18, by the way. So we replace the a with minus 1, and this is actually plus 3, so this is actually minus 15, and we add 15 to both sides, we get b. Now the next part, second complex root. So previously we know that u is a root. This is u, which means u star, the conjugate, is also a root. The conjugate is exactly the same, but with the opposite imaginary part. So if this is plus, it is minus. If it's minus, the other one is plus. Okay, find the real roots of. So previously we know that u is a root, which means x minus u is a factor, and this is the conjugate, so x minus that conjugate complex is also a factor. So previously we know the value of a and b, so a and b, we plug in the values, so we can factorize this. We get this factor and this factor, plus we have another linear real factor here. So to multiply here, just open up the brackets. Minus 1, minus 2, minus 1 plus 2, and if you just look at this form, this is actually a minus b, a plus b, the difference of two squares, and we get a squared minus b squared. This is a squared, this is b squared, and if we expand, we get x squared minus 2x plus 1, and this is 4i squared. I squared is minus 1, so minus times minus 1 is plus. So if we simplify, we get 5 here. And now to find the m and n. So if we look at the left hand side, just look at the x cubed term. 2x cubed. The only way to get 2x cubed is from x squared times mx. So when we multiply x squared times mx, we have to get 2x cubed, which means obviously the m is 2. And if we analyze the constant term here, the 15, the only way to get 15 is when we multiply this constant from this quadratic factor times this constant from this linear factor. So 5 times something equals 15. So the n is therefore 3. So that's why we have the m is 2 and the n is 3. So for the real factors, we have the quadratic and the linear. Now sketch. So z minus u. So if we have the absolute value of z only on one side, this is the locus of a circle. So this is a circle. To identify the center, we gotta make it z minus z1 form. This is the center of the circle, so it's 1, 2. The radius is root 5. Smaller than means we shade inside the circle. So you don't need to draw this, but just to visualize things, this is the center 1 minus 2, and the radius is root 5, which means the circle should touch the origin. Because if you look at the radius here, so this radius, which is the hypotenuse of this right angle triangle, square root of 1 plus 2 squared, that's going to be root 5, which is the radius, so it's supposed to touch the origin. And for this locus, this is the locus of a half line. Whenever you see arc something, that's a half line. To find the starting point, we make it z minus something. So because there's nothing, then it's z minus 0, 0 here. The starting point is 0, 0. And the angle is smaller than minus 1/4. So smaller means from minus pi to this value. Okay, so this is the part we shade actually. Okay, so all we need to draw is this one actually. Okay, so we combine the circle and the half line and we shade the intersection. So this is the final answer. And now find the least value of the imaginary z for points in this shaded region. So the imaginary means the imaginary part. So the z is the line from origin to any point in this shaded area. So this can be z, any point. But since we want the imaginary value to be the lowest, that's gonna be when the point is here at the lowest part. So to find the imaginary part, first of all, we know that the radius of the circle is root 5, and from the coordinates of the center we know that this distance is 2. So to get the difference here, we get root 5 minus 2. That would be this y coordinate or imaginary coordinate, which is minus something, so it's going to be negative. So root 5 minus 2 is the positive value of the distance, but for the coordinates, the imaginary part would be negative this length. Okay, so it's negative this length, so the final answer is 2 minus root 5. Okay, it is not root 5 minus 2 because obviously this is negative something for the coordinates of this point here. Alright, I'll see you again next time.